Okay, so here we're asked to solve each trig equation. So a couple things to remember about problems like these here is that first of all, when we are asked to solve, we're trying to find x, and any number that's inside of sine or cosine or tangent, we know that's an angle. So remember, our answer here should be an angle measurement. Now, for this one here, it says for anything between 0 and 2 pi, which should alert us to the fact that we're not talking about degrees anymore, because that would be 0 to 360. That's a whole circle. If we're saying 0 to 2 pi, we know we're dealing with radians. So especially if we're going to use a calculator on this problem, which we are, your calculator should be in radian mode. So make sure to click mode, scroll down, and change it to radians if it's not there already. Okay, so from here, first thing I'm going to do is I want to get that trig function by itself. So I divide both sides by 3. I get sine of x equals 1/3. And let's just sketch this out to see what that looks like. Remember, when we're talking about sine on a unit circle, we're talking about the y value. So if the top of our unit circle is 1, which it always is, then 1/3, let's call it the y value about right here. And that really should give us two different points because there are two spots on the unit circle that our y value is 1/3. This spot right here and this spot right here. So for this first little mini angle, I'm going to find that by using the inverse of sine. So I'm going to continue doing my algebraic method here by taking the inverse sine of both sides. I get sine -1 of 1/3. And 1/3 is not one of those beautiful, pretty answers that's going to give me a nice, perfect number. So I'm going to use a calculator, plug it in. I'll round my answer here to about 0.3398. And when I'm trying to find my other angle, because this is my first answer, but as we said before, there's two. When I'm trying to find this other angle here, really what I want to do here is subtract my little red angle there from pi, because this whole half circle is pi. So let's go in blue here. So we got pi, which is the whole half circle, but if I subtract 0.3398, right, I'm taking away this little section, and then that will give me my final second answer, which again is an approximation, but is about 2.8018. And a reminder that these are in radians, so my two answers here are not a really tiny degree, it's an actual radian. My second problem here, similar idea, but it's a little bit different. First of all, I don't have to do any division, it's already by itself. But again, I want to just sketch this out to remind you that when we're dealing with this, 3/4, let's say it's here, there's two spots where the y value, because of sine, is 3/4. So I need to find two different ones to start. And so the first one here, again, I just use the inverse sine. So inverse sine, x equals the inverse sine of 3/4. If I plug that into a calculator, I get about 0.848. And then I need to understand that because it says for all values of x, I could technically go all the way around the circle and get that same answer. It would spit out the same thing. And so I take whatever angle I'm getting and adding 2 pi n to it, because I could just go around the circle as many times as I want. So there's the first part of my answer, but remember, I have to deal with this second spot here, this larger angle. And to do that, I'm going to subtract it from pi, right? Because that's the whole circle, and I'm going to subtract that little half that I know. So this one here, it's pi minus 0.848, which is about 2.29-ish. And then I'm going to add 2 pi n because I can go around the circle as many times as I want.